So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are going to be proving this relation down. Actually, you know what? We were just like looking around with the hypergeometric function, right? Gauss hypergeometric function. So I think yeah, this is the one we should look for after the most basic, the most fundamental. That was the Euler's integral representation of the hypergeometric function, right? So yeah, using the Euler's integral representation of the hypergeometric function, we're gonna be proving this relation actually. So this states that the hypergeometric function, the basic, is equals to the 1 minus z to the minus a, and another hypergeometric function actually evaluated at a, c minus b, c, and z over z minus a. 1 actually, I'm sorry, 1. Wait a second, I need to just plug. Yeah, now it sounds good. So let's just get back to the proof. So yeah, here we are with the proof. Okay, so yeah, this was the thing that we are here for to prove down actually, right? So let's just talk about the proof. So yeah, we already know that Euler's integral representation, right? So it's the hypergeometric function is being represented as gamma of c over gamma of b times gamma of c minus b times the integral from 0 to 1 of t to the b minus 1 times 1 minus t to the c minus b minus 1 times 1 minus t times z whole to the minus a dt, right? So this was the thing we have proved it, right? We have proved this, and now with the help of this one we are just gonna be proving this amazing relation, you can say. Not amazing, but yeah, it's useful and it's pretty good. We'll learn about the hypergeometric function actually. That's why I'm just requesting you to just take a look at the proof of this thing. And yeah, it's gonna help us a lot in proving the higher things, right? So, and you know what, if your foundation of your building is strong, then your building will be stable, otherwise it's gonna collapse. So you need to be careful about that. Okay, so let's just not go into philosophy, let's just talk about mathematics. So now let's just take a look at this thing. This is the part of our integrand in this integral, right? How you can see right over here. So we're just gonna take a look at this one in detail actually. So 1 minus t times z can be written as 1 minus z plus z times 1 minus t, right? Actually, when you're gonna solve this, so you're gonna get back to this one. So yeah, it's 1 minus z and plus z times 1 minus z times t. So minus z and plus z cancels out, and we would be having 1 minus t z. So this implies 1 minus t times z equals, we can factor out this 1 minus z, right? So that's going to be giving us 1 minus z times 1, actually this, I'm talking about this one. So it's 1 plus z over 1 minus z, like yeah, dividing with this one as well here, and 1 minus t, what we were having over there. Okay, and now we are just gonna raise this equation to the negative a power. So it's negative a. So yeah, you can see right over here, yeah, and this one, right? Okay, let me just erase this down. Okay, so it's pretty fine. And now we are just gonna substitute this back into our original integral, or you can say on the place of our integrand. So yeah, obviously this 1 minus z to the minus a is not depending on t, so that's why it's just gonna be factored out as we have done this here. It's the hypergeometric function equals 1 minus z whole to the negative a times gamma of c over gamma of b times gamma of c minus b times the integral of t to the b minus 1 times 1 minus t to the c minus b minus 1, and times this thing actually. So yeah, and it's 1 plus z over 1 minus z times 1 minus t and whole to the negative a dt. Okay, and now this you can say this substitution is Euler's clever substitution, you can say. And yeah, it is clever substitution obviously, and yeah, we cannot comment on Euler. He was a great mathematician. and I think we will not be able to see that kind of mathematician ever in future, right? But it's all right, nothing is impossible. So let u equals 1 minus t, so t is going to be 1 minus u obviously, and if we talk about the derivative, so dt is going to be minus 1 times du, right? So our fundamental you can say the hypergeometric function is coming out to be 1 minus z whole to the negative a times gamma of c over gamma of b times gamma of c minus b times the integral from 0 to 1. Actually, you know what, if we talk about the limits from here, so your lower limit is gonna be 1 and your upper limit is gonna be 0. So like, yeah, it's the integral should be from 1 to 0, right? But because we are having the derivative like this negative over here, so I have just used this negative sign in order to switch this the limits, right? So that's why we are having the perfect, or you can say the legal integral, that is the integral from 0 to 1 of this t is 1 minus u, so it's 1 minus u to the b minus 1 times u to the c minus b minus 1 and times 1 plus z over 1 minus z, and it's u whole to the negative a du. Okay, and now taking another look at this thing, another the part of the integrand actually that we have done so far, right? So we can just talk about this when we can write this as 1 minus z plus zu whole to the negative a over 1 minus z to the negative a. So this can also be written as 1 minus z to the a, and it's 1 minus z plus zu to the minus a, right? So yeah, it's not that difficult to just look at, but yeah, it's pretty fine. And yeah, so now let's just plugging this back on the place of here. So that's going to be giving us, again, this is independent of u, so that's going to be plugging out of the integral, and we would be having this thing equals 1 minus z whole to the negative a times 1 minus z whole to the positive a. So yeah, we will be having some sort of good cancellations over there, and times gamma of c over gamma of b times gamma of c minus b times the integral from 0 to 1 of u to the c minus b minus 1, right? We are just running over that track only. Actually, I have just written that stuff right over here and this one right over there. So 1 minus u to the b minus 1 and times 1 minus z plus zu whole to the negative a du. Okay, and now our next step is obviously just canceling this stuff down and just copying down the rest of the things. So that's going to be giving us the hypergeometric function equals gamma of c over gamma of b times gamma of c minus b times integral from 0 to 1 of u to the c minus b minus 1 times 1 minus u whole to the b minus 1, and it's times 1 minus z plus zu whole to the negative a du. Okay, and finally taking a look at this integrand, the part of the integrand actually, that is 1 minus z plus zu whole to the negative a. So this can be written as 1 minus z whole to the negative a, just factoring out 1 over, you can say factoring out 1 over 1 minus z whole to the a. So that's going to be giving us 1 and plus z over 1 minus z u whole to the negative a. But I have just used this thing as z minus 1, or you can say just taking out negative common, so that negative is written over here, right? So I hope you can understand that, or let me just explain it to you. So basically it's 1 over 1 minus z to the a, right? And it's, if we factor it out, so that's going to be giving us 1 plus z over z minus 1 times u whole to the negative a. And here I have just factored out this negative, so that's going to be giving us negative here. So that's why it's just written something sort of that. It's 1 minus z to the minus a and times 1 minus z over 1 minus z to the minus a, right? So yeah, that was the thing, and I think I would have elaborated that, but it's all right. I have just explained it to you here. So yeah, I hope you are done with this, right? Okay, so basically just plugging this back on the place of there, so there actually, so that's going to be giving us, again just factoring out this thing, so that's going to be giving us the hypergeometric function equals 1 minus z whole to the minus a times gamma of c over gamma of b times gamma of c minus b times the integral from 0 to 1 of u to the c minus b minus 1, and 1 minus u to the b minus 1, and it's 1 minus z over, actually wait a second, z minus 1 times u whole to the negative a du. Okay, and now comparing the integral and factors with the Euler's integral representation. So yeah, let me just compare it to you, for you actually. Okay, so we have this integral, this was the Euler's integral representation, right? So our u our u is being raised to c minus b minus 1. So now we can just say that b is being replaced with c minus b, obviously. And for here we have 1 minus t is raised to c minus b minus 1. So here we can also copy that, or you can say that your 1 minus u is being raised to b minus 1. So basically the one thing that we should notice is b is being replaced with c minus b, right? And if we talk about z, and a and c will be rest, like it won't bother us, right? Okay, after looking at both the integrals. And if we talk about z, so look at this, it's 1 minus t times z, right? And here we are having 1 minus is this part, so basically your z is being replaced with z over z minus 1, and rest of the things are perfectly fine. So after just replacing all the things according to the integral that we have got so far, we can say that this part is defined by this thing, this hypergeometric function. And finally we can say that yeah, hence proved, and this is the thing that we were looking for actually. So yeah, it was good, and we got to learn something, but not a lot of thing, but yeah, something I can say surely. So again guys, if you got to learn something out of it, please make sure to like, subscribe and share. And if you have any kind of doubt so far, you are free to ask me in the comment section. I'll be there to reply over your questions. Thank you so much for watching this video guys. Goodbye, take care, love you, love your life, love mathematics, and just learn everything from everywhere. Goodbye guys, love you, take care.